So in this video, we're going to talk about speed and velocity and average velocity. So when you're talking about speed and velocity, both of these terms are used to describe how fast something is moving. And often in everyday language, we use speed and velocity interchangeably. But there are differences between the two when you're talking about physics and what their technical definitions mean. The easiest way to tell the difference between speed and velocity is to look at how you calculate them. So speed is equal to distance divided by time. Velocity is equal to displacement divided by time. Now, if you remember about distance and displacement, first off, distance is a scalar, displacement is a vector. So speed is also going to be a scalar, which means it's not going to have a direction. Velocity is also going to be a vector since it's based on displacement, and velocity will have a direction. So that's the first difference between them. Now, since speed is distance divided by time, if I start here, move there, 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 remember I'm going to add up all of those different movements to get my total distance. Then I'm going to divide it by the time that it took to do all of that. So again, no direction. Velocity is displacement divided by time. So remember, if I start here and I move those same movements for displacement, I would not add all those together. I would just be concerned with the distance between point A and point B, no matter what happened in between, divided by the time it took to get there. So velocity is based on displacement. If you're going in a straight line, then the distance you travel is going to be the same as your displacement. And so speed and velocity would be the same except for the direction part. But if you have twists and turns, then these two are going to be different numbers. So let's look at this problem. Lucas rides his bike 2,300 meters west to the park, and it takes 12 minutes to get there. What was his speed and his velocity? Okay, well, if we're looking for speed, speed was equal to his distance divided by time, and velocity was displacement divided by time. Let's find his speed first. So he rode 2,300 meters west to the park, and it took him 12 minutes. So our distance was 2,300 meters. And since it's distance, we don't care that it was west. So this is just 2,300. Now it took him 12 minutes to get there. What was his speed? So now that I've set it up, 2,300 divided by 12 is 191.666. So we'll just ride 192 meters per minute. Okay, so our units are right here. Now meters per minute is not the normal unit that we would use. You see miles per hour a lot, but the standard metric unit for speed and velocity is going to be meters per second. So I'm going to show you how to convert this. Well, if I wanted this to be in seconds, then instead of using 12 minutes, I could have put the number of seconds there. So 12 minutes, there's 60 seconds in a minute. And so I'm just going to do 12 times 60. Most of you can do that in your head, or at least set that up in your head. But we are also going to use something called dimensional analysis. So if you're not sure if you're supposed to multiply by 60 or divide by 60, you take what you have, 12 minutes, whatever you have up here that you want to get rid of, you put it on the bottom. And then we're trying to get from minutes to seconds. So this minutes is going to cross out. It's going to cancel out. We know that 1 minute is 60 seconds. And so you can see here you're going to multiply. So anything on the top gets multiplied, anything on the bottom gets divided. Those divide out. 12 times 60 is equal to 720 seconds. There's the unit we were looking for. So what we could have done was done 2,300 meters divided by 720 seconds. and that would give us 3.19 meters per second. Both of these mean the exact same thing. So if I'm going every second 3.19 meters, then after a minute, I'm going to hit 192 meters. This is about times 60. So either of those are the right answer, but generally you would want it to be in the correct units, which is meters per second. Now let's look at how velocity would be different. If we're finding the velocity, remember velocity was displacement divided by time. Displacement was our change in position divided by the time interval. This little delta means change in, and so the change in x, or the change in position, divided by the change in time. Okay, so I don't have an eraser, so we're just going to scratch that out so I don't have to start over. What I meant to write first, velocity is our change in position, and so change in position is your final position minus your initial position, divided by the time interval, which would be our final time minus our initial time. We don't have final and initial, so the change in time. Our final position was 2300. Technically it was west, so that's negative 2300. You usually use west as negative, south as negative. Minus our initial position was 0, it was at the origin, divided by our change in time, which was 12 minutes. We'll go ahead and use 720 seconds to get this in meters per second. So here you see that the only difference is that this is going to be negative 2300 divided by 720, which is going to give you negative 3.19 meters per second. So in this example, in which you went in a straight line, you got the same number, 3.19 meters per second. The velocity is negative since it was west. Velocity has direction, both magnitude and direction, whereas speed is a scalar, so it doesn't have direction. So here's an example where you get the same number, essentially, for both of them. So let's look at this example. Lisa drives 5 miles due east for 5 minutes to the grocery store, and then drives 3 miles and 9 minutes due south to her mother's house to cook dinner. What's her speed and the magnitude of her velocity in both miles per hour and meters per second? So let's start off with a picture. So she starts wherever it is at the origin. She goes 5 miles east and then 3 miles south. Now, the first part of her trip took her 5 minutes, and the second part of her trip took her 9 minutes. So if we're talking about speed, speed is equal to distance divided by time. And we're talking about this whole trip. So the distance she took in the trip, she went 5 miles and then 3 miles. So her distance is 8 miles. And it took her 5 plus 9, 14 minutes. Now, we don't really want minutes. We'd like to do miles per hour and meters per second. So let's really quick figure out miles per hour. And so let's figure out how much 14 minutes is of an hour. So 14 minutes. Again, some of you can figure this out really quick in your head, but getting used to this process. Whatever you have, minutes goes to the bottom because we're trying to get rid of it. So it's going to cross out. We're going to go from minutes. Let's figure out hours. So 1 hour is 60 minutes. There's our conversion factor. So minutes goes away, and we're going to do 14 divided by 60. Multiply what's on top, divide by the bottom. And you get 0.2333 hours. So here, instead of doing 14 minutes, we're going to divide by 0.2333 repeating hours. And that's going to give us 8 divided by 0.2333, 34.286, which is going to round to 34.3 miles per hour. Now, if we want to convert this miles per hour into meters per second, because the question asks us for meters per second, 34.3 miles per 1 hour. That's what miles per hour means, how many miles you go in 1 hour. We're trying to get to meters per second, so I want to convert miles to meters. Miles is going to go on to the bottom. Meters goes on to the top, so that way miles cancels out. Now, you may not know this, but I know that 1 mile is equal to 1,609 meters. That's something to memorize. Now, I still have to get rid of hours. So I want to get hours and turn it into seconds. Since hours is on the bottom, to get it to cancel out, I have to put it on top to divide out. So I'm going to go from hours to seconds. Well, 1 hour is 3,600 seconds. Another thing to memorize, 60 seconds in a minute, 60 minutes an hour, 60 times 60 is 3,600. So now my miles have canceled out, my hours canceled out, and that leaves me with meters per second. That's the unit I'm looking for, meters per second. So I'm done, except I have to still multiply and divide. Multiply the top, divide by the bottom. Sorry for the scribbles, I made a calculator error and I don't have an eraser. So when you multiply the top, divide by the bottom, you end up with 15.33, so 15.3 meters per second. So 34.3 miles per hour is the same as 15.3 meters per second. Now let's look at velocity. Velocity is equal to displacement divided by time, which is change in position divided by time. So what was our change in position? We started here, we ended up here. Pythagorean theorem, we did those. We have a right triangle. And so we have to real quick figure out what our displacement was. So displacement is going to be the square root of 5 squared plus 3 squared, which is 5.831. So right now we see a big difference. When we were determining speed, that distance was 8 miles, but our displacement for velocity is only 5.831. It's going to take the same amount of time. The time interval is the same. And so for miles per hour, we saw the same time, which is 0.2333, which gives us 24.99, or essentially 25 miles per hour. So this one covered more distance than it did displacement. Distance and displacement will always either be equal, or distance will be farther than displacement. And so that ended up getting a higher speed than the velocity. Now it's also, she ended up going kind of southwest. Now you're supposed to have a direction. To get the actual direction, we would need to know this angle here. So I'm not going to write a direction. Plus it says the magnitude of the velocity. But we would need to know that angle, and we don't know it, and we're not going to calculate that right now. We will later. So the magnitude of her velocity is 25 miles per hour. Now, what is that in meters per second? We're going to go through the same exact process here, except instead of having 34.3, we're going to do 25. So it'll be 25 times 1609 divided by 3600. And you get 11.17 meters per second. Now, I'm not worrying about significant figures in these particular problems. So if you're worried about significant figures, then you could definitely round those more. But we only had one significant figure in each of these, so this answer would be 10. So we're not worried about sig figs right now. Okay, so are speed and velocity the same thing? No, they're not, because the speed was 15 meters per second and the velocity was only 11 meters per second, because the displacement and the distance were not the same. Let's do another example. John's plane flies for 3.4 hours at an average velocity of 350 kilometers per hour. What was his displacement in both miles per hour and meters per second. For the sake of time, let's just do kilometers per hour. So we're looking for his displacement. So displacement, we know that velocity is equal to displacement divided by time. If I were looking for displacement, how could I rearrange this problem? Well, we need to get displacement by itself, which means we have to get time over there. How are you going to do that? Well, you're going to multiply this side by time, and you're going to multiply this side by time, and that gets rid of time over here, leaving you with displacement. So you find that displacement is equal to velocity times time. We know that his velocity is 350 kilometers per hour. We know that his plane flies for 3.4 hours. So we're going to multiply velocity times time, 3.4 hours. So notice that our hours are going to cancel out, leaving us with just kilometers for our unit, and that makes sense. 350 times 3.4 is equal to 1190 kilometers.